So we're going to continue talking about numerical distributions. We're going to finish that up. We're also going to be ending a little early because my daughter has a orthodontics appointment she needs to go to. So we're going to finish at like 1:45 or so. Okay. And so we're going to continue with numerical distributions, finish that, move on to categorical distributions. So let me go to writing mode. There we go. Awesome. Okay, so last class we started talking. Let's scroll back up a little. So last class we were finishing up center and spread, and one of the things that we discussed was that. Oops, why can't I see? 1 second. Sorry. There we go. One of the things that we discussed was that center and spread, they come in pairs. So certain measures of center go with certain measures of spread. And we talked about how mean as a measure of center and standard deviation as a measure of spread go together. We also discussed what is spread. And we found out that spread tells you how far from typical subjects typically get. So it sort of it gives a spread to what you think constitutes normal or typical. Okay, we did some examples. And we talked about how mean and standard deviation, or you only use them if the shape of your distribution is symmetric. So after we discussed that, we talked about skewed distributions. What do you do if your distribution is skewed? So if you have a skewed distribution, you're going to use your measure of center is going to be the median, and your measure of spread is going to be the IQR. I showed you how to calculate the median. So it was sort of annoying, but what do you have to do if you want to calculate the median? Do we remember? If you're calculating the median, what are the steps involved? No, that's the mean. That's the mean. Yeah, so the median is finding literally the number in the middle. So first you have to put them in order. That's you can see right here, I started off with the number of pets. Oops, why is it not writing? What the hell's going on? Oh, wow, what the... Okay, there we go. There's my little arrow. We start off with the number of pets, and then we ordered them, right? And then you start on the edges and you cross them out until you get to the middle, right? Yeah. Okay, so the median, we found out it's because it's the number in the middle, 50% is greater than it, 50% is less than it. And one of the things that we talked about was the outliers don't affect the median. So we have a special name for that. It's called robust. All right, so if you because the median is just the number in the middle, if you change the number on the edges, nothing happens. So in statistics, there's a specific term for that. We call it robust. It's not changed by the presence of outliers. Okay. And then we moved on to some other stuff. So what we did was we found our median, which was in the middle, right here. And then we took the bottom half of the numbers, all the numbers less than the median, and we found the median of that. That was called Q1. Now, Q1 is special because 25% of the numbers are less than Q1. For the median, 50% of numbers are less than the median. And then we took our top half, the numbers greater than the median. We found the median for that, and we called it Q3. Okay? And the whole point of doing this is that these numbers, Q1, the median, and Q3, they split your data into 4 equal parts, each which are 1/4 of the data. So Q1, the median, Q3, split your data into 4 equal parts, which are each 25% of the data. That's why we call them quartiles. Okay, it splits your data into 4 equal parts. And we're going to look at this today because it actually tells us some really interesting stuff about the data. Like, what are these quartiles? Okay, so I'm going to open up Wolfram, and we're going to be doing that. Just give me a moment to open it. So I'm going to leave this here. Oh yeah, and then always, as normal, I invite you to turn on your cameras because I get lonely looking at your gray boxes, if you wish. No pressure. Oh, thank you. Okay, so I'm opening this stuff. Okay. So let me change the view, magnification 200. There we go. Perfect. Okay, so I'm going to change my screen now so that you can see Wolfram. Okay, come on. Okay, do we see Wolfram? Yeah, I think we do. Okay, so remember we looked at the age at marriage data set? Like, we looked at like how old women were when they first got married. So we're going to go back to that data set. It's right here. So I'm going to copy this data. Or actually what we're going to do is, yeah, we're going to copy it and look at it. So I'm going to go copy. Okay, wait, nope, that's not working. Copy as image. No, did it do it? Oh my god. Sorry. Sometimes just like the computer just goes crazy. Okay, that didn't work. Okay, I want to copy this. Copy as image. Oh, there we go, finally. Okay, copy image. Okay, I'm going to paste it back over here. Okay, let me change the size, and we're going to go back. There we go. Okay, let's make it a little bigger. Okay, so let me change us back to looking at, because I copied the picture. We want to look at this picture. Okay, cool. Okay, so the variable here is the age at first marriage. And what is the type of graph we're looking at here? This is a what? You have a name for this sort of graph. Yeah, histogram. Awesome. Okay, and we can use the histogram to figure out the shape of the distribution. So what's our first step to figuring out the shape of the distribution? The mode. You want to find the high point, yeah. They have very similar names. So our most commonly occurring value is the mode. You find the high point of the graph. And apparently, what's the most common age at which women first get married, according to this data, approximately? Yeah, cool. So apparently, the most common age at which women get married is 21 years old. Now, to figure out the shape of the graph, I now need to look at the tails. So I'm going to measure out my tails. The right tail goes from 21 to approximately, apparently what's the oldest age at which women get married? What is that? Yeah, like 42 or something like that. So how wide is this? So my right tail is about how wide? Like 21, right? Okay, now we have to look at the left tail. It ends like right here. What's the youngest age at which women get married? And remember, this is in the US. Yeah, like 12, 13. A little weird. We're gonna take a quick detour to talk about this. We're going to look at legal age of marriage in the United States just for a moment to shock you and possibly depress you. There's a Wikipedia article about this. I googled legal age, marriage age in the United States. So they have like a cool little, what's the word, like table where you can look. So minimum statutory age after all exceptions. In Massachusetts, a 12-year-old girl with certain exceptions can get married. A 14-year-old boy can get married. In Hawaii, it's 15. In Kansas, it's 15. In Maryland, it's 15. Mississippi, 15 for females, 17 for males. So anyways, you can look through a lot of places you can get married at 16, like tons of them. 17. No, minimum statutory age after all exceptions. So general marriage of age is basically 18. But there are exceptions. So like with your parents' approval, you can get married in California at like the age of, let's find out. In California, up until shit. So apparently you had to be 21 to get married in California prior to 1971. Then they lowered it to 18. And it used to be that with certain exceptions, you can get married at 15. Does that make sense? Like that would be your parents' approval, or like if you get emancipated or something like that. So there's technically two different ages at which you can get married, like depending upon the legal situations. That's why you have this. So yeah, you can get married at 12 apparently, with parental consent or judicial approval in Massachusetts. So that girl must have been from Massachusetts. So yeah, there you go. Crazy, huh? Yeah, it's pretty nuts. So back to what we were doing. I always like to point this out when I'm teaching this class, when we look at this data. Okay, so how wide is my left tail? Approximately. You go from 13 to 21, that's 8, right? So what sort of shape do we have here for our distribution? Skewed. And in particular, what sort of skew? Because you don't just say skewed. Yeah, right skewed. Because the right tail is longer. Now, because we have a right skewed distribution, what are the appropriate measures of center and spread that we're supposed to use? So remember I was saying, like, depending upon the shape, you'll use different measures of center and spread. So because the shape is skewed, what's the measure of center that we're going to look at? I'm going to duck face while people think. Oh my god, I saw people's eyes like twitch to the side. I think that was hilarious. Yes, median! And the measure of spread will be IQR. If it was symmetric, then we would have used mean and standard deviation. So does that make sense to everybody? Like, because it's skewed, you use this pair, median and IQR, but if it had been symmetric, you would have used this pair. Okay, so it's really important to look at the graph first, because you need to choose which one you're going to deal with. Okay? Bueno so far? Okay, so we're going to go back to Wolfram, and we're going to find out what these numbers are. So let's do that. So here we are in Wolfram. And I'm going to reload my data. So I called my data data. Actually, let's rename it. Let's not call it data. Let's call it age. Age mar for age marriage. Okay. So I want to calculate. I'm going to take my age mar data I want all the rows, and I want the age variable. And I'll put // and I want to know the median. Okay. So apparently, the typical value or the typical age at which women get married is, because we are using the median, is 23. So I'm going to write this down and say we looked at the histogram. The shape of the distribution is skewed. Okay, what? Okay, weird. Is skewed. Thus, our measure of center is median, and our measure... Okay, why does it keep doing this? And our measure of spread is IQR. So now we know that the typical age at which women first get married is 23. I don't know why it's doing that. It just keeps like bouncing around. Okay, and then we can have it calculate the median for us. We can say, take our data, age mar, all rows, age variable, // and we can put in IQR. And it will calculate it for us. Okay, wait, what the hell? Oh, my bad. You have to literally type interquartile range, not just IQR. Interquartile range. The IQR is what interquartile range stands for. Okay, why did it not do it? Huh. What the hell? Okay, 1 second. I need to look at a book. Like, it's giving me an error. Give me 1 moment to figure out like why it's not doing this. 1 second. Okay, according to my book, I think the command I need to put is normal. Please. Oh, thank God. Yes, it worked. Okay, cool. So, what does this mean? So, if you were to guess one number about how old women are when they get married, it would be 23. But the 6 tells you that you can go 6 in either direction. So if you were able to, if you wanted a range of values, you could say, well, the IQR tells us that women typically get... What the hell? Married. Okay. Married. I start typing and it keeps on bouncing around. Between, what's 23 minus 6? Yeah, between, and then 23 plus 6 is 29. Yeah. Yeah. Mm-hmm. Oh, just by like looking at the histogram? Like looking at that? Uh, Almost zero chance. There's actually another graph that I'm going to teach you about that would help you with that. But that's a good question. That it's pretty hard to just guess by looking at it. Okay. So the median is the measure of center. That's the 23 we calculated. You got our IQR that gives you like this range of values. Like actually maybe anywhere between 17 and 29. So there's a graph that will help you look at this. So we're going to learn about another graph. If you're dealing with a skewed distribution, it is preferable to use a box plot instead of a histogram. Okay, and we're going to look at that. So we're going to take our data, all the rows, the age variable, and // and instead of writing histogram, now we're going to type in box whisker chart. So the command to make the box plot is box whisker chart. Okay, and I'm going to copy this, and we're going to copy it, and we're going to take it back to the notes and look at it. So I'm getting that ready. There we go. Oh shit. Okay, so we're going to look at this graph in the notes. I'll give you a moment to write this stuff down. Oh, whoa, I'd never even noticed what BB said in the chat. Their cousin was very young when they got married. I'm assuming this is not in America, or in America. It's hard to say now, given what we found out when we looked on Wikipedia. If you want to answer that question. But I'm going to switch us back to go to the notes. And we're going to look at the box plot. Maybe BB will give us an answer, maybe not. Okay, so this is our box plot. So the box plot's a little weird because you look at it vertically. So if you look at this, do you see how it says 40 here, 30, 20, 10? That's the variable. So in other words, the higher up you go in the graph, the older the woman was when she got married. So this is that age at first marriage. Okay, and there's several different parts to the graph. Let's look at this part. What part of the graph, what do you think this part of the graph is called? It's called a box whisker chart. So this part in blue, what do you think you call that? That was, oh my god, that was great. Mommy, no! Who was that out of curiosity? I'm just curious. Is it you, Beatrice? That was hilarious. Someone. Oh, Mommy, no. I miss those days when my kids were little. Yeah, so that's the box. This part, these are the whiskers. I mean, sort of makes sense once you give the name. Okay, there is a line in the box. Right here. And I'm going to draw over so you can see approximately what number value is that line at. So did you see how I drew a line over so you can see like where it matches up? Yeah, exactly. This is 23. You're always going to have a line in the middle of the box, or you're going to have a line somewhere in the box, and that's always the median. So that's your median. So when you look at a box and whisker chart or a box plot, you're going to have your box, and in the box somewhere is going to be a line. That's your median. Okay, and then you have two other lines. So approximately at what value does that line seem to be? About 20, right? And approximately this value is like, I don't know, 25 or so. Okay. Those numbers are Q1 and Q3. So the box starts at whatever Q1 is and ends at whatever Q3 is. And somewhere in between them is the median. Now let's look at the whisker. How low, what value does the whisker seem to be at? That was the youngest age. So this starts at the minimum, which is the smallest value. Which means actually apparently in our data set, how old was this quote-unquote woman when she got married? Not 13. Actually, 10. We read the graph wrong earlier. Apparently it didn't start, the little box didn't start at 13. It actually was 10. Now, the other whisker, let's see how far that one goes. What number does this appear to be, approximately? Throw something out there. Cool. That's the maximum. So in other words, the oldest a woman got married at for the first time was 43. How young was a woman when she first got married? 10. So the box and whisker chart tells you a lot of cool stuff. It gives you the minimum, the smallest value, the maximum, the largest value. It gives you the median, the typical value. And it also gives you Q1 and Q3. Right. So remember the way it works is Q1, the median, and Q3, split up your data into 4 parts. So you start at the minimum to the Q1, Q1 to the median, median to Q3, and then Q3 to the maximum. Do you see how there's 4 parts there? Part 1, part 2, part 3, and part 4. Because you're splitting your data into 4 parts, how big are they each? Or how big are each of them? So if you take your data and split it into 4 parts, how large are each of those parts? I'm dancing while you think. With my hand like this. So you have your whole thing, you split it into 4 parts. How big are they each? Relatively. Yeah, 25%. Yeah, exactly, yes. And that's why we call them quartiles. So, you look at between the minimum to Q1. That's 25% of women. So we can write that. We can say we know that 25% of women get married for the first time between what ages? 10 and Q1 was 20. How do I know this? Because between the minimum and Q1 is one of those quartiles. In other words, there's 25% of women who get married will get married between the ages of 10 and 20. That's actually sort of crazy when you think about it. 25% of women will get married between the age of 10 and 20. What's the next quartile that we're going to deal with? So this one went between the minimum and Q1. What does the next one go between? Not minimum. Or Q1 and the median. So in other words, 25% of women will get married between the ages of 20 and 23. That's between Q1 and the median right here. This part. Okay, I can't get rid of that. What's the next one going to go between? The median and Q3. 25% of women will get married between the ages of 23 and 25. And then the last one will be Q3 to the maximum. 25% of women will get married between the ages of 25 and 43. Which is sort of crazy, because if you look at those first 3, together what percentage do they make up? Those first 3 groups. Yeah, 75% of women will get married before what age? Yeah, which is actually, I've read these interesting articles about women in China. Does anyone know? There's like this special age apparently in like mainland China where it's like, oh, if you aren't married by now, you're probably fucked in terms of finding a husband. Does anyone know what that age is? It's 28, and actually that makes sense because if you aren't married by the time you're 25, you only have a 25% chance that you'll get married after that. I mean, I don't know if that's a thing for you, but anyways, I'm just saying, like, if you look at it for the numbers, I'm not passing judgment about whether you should or shouldn't get married. I'm just saying, like, if you don't do it by the time you're 25, you have a 25% chance left. Which is sort of interesting when you think about it that way. So you can get, like, really analytical about this if you want to. So, and it's pretty crazy because, like, sounds like I'm never getting married then. Well, I mean, you still have a 25% chance. Who here is between the ages of 20 and 23? Just put F in the chat. If you're a woman between the ages of 20 and 23. There's like a 25% chance that like you'll get married like in that little age bracket there. It's like pretty nuts when you think about it. So, yeah, you can look at all this information and you can start seeing there's patterns. Like by a certain age, if you're probably not going to get married if you haven't already. Now, why are we looking at this? Not because, like, I want to be sexist or something or patriarchal, but because the box plot, right? It tells you, like, all the women in this whisker right here, they have an equal chance of getting married as all the women in that part of the box and is in that part of the box and this whisker, right? Each of those groups is actually the same size. Okay, and that's how you read it. Wow. Okay, we're going to end here today. I'm going to stop